All my listeners and viewers are welcome to another physics class. Today we shall be talking about resultant of more than two factors. When we have more than two factors acting at a point O on an object, what do we have to do? We have to resolve all the factors into two. We have to resolve all the factors into vertical and horizontal. Like in the example on the board, we have three factors. We have five rather. 1, 2, 3, 4, 5 factors acting on an object. We have 10 Newton acting vertical. We have 3 Newton acting vertical but in the opposite direction. We have 8 Newton acting towards the east, which is the horizontal. We have 20 Newton, which is acting in between. It has both horizontal components and vertical components. We have 6 Newton that have horizontal components and vertical components. So all these 5 factors must be resolved into two, into vertical and horizontal. How do we do that? We shall observe that in the next slide. So as you can see on the board, we have to resolve them. So this 20 Newton has horizontal component towards 8 Newton and it has vertical component towards 10 Newton. So as it is, we can also look at this 5 Newton. It has horizontal component and then it has vertical component, which is in the negative side. So for this one, we can bring out a kind of a triangle where 20 Newton will be at the middle. You have 30 degrees here, and this will be your right angle. So that means this is your adjacent side, which is the horizontal component of the 20 Newton. And this is your opposite side, which of the 20 Newton. So with this now, if you apply trigonometry, using trigonometry as you have been taught in the previous class. So if you are to find the adjacent and hypotenuse, this is your hypotenuse. So if you are to find this adjacent, whereby you have theta and then you have hypotenuse. So that means cos 30 degrees will be equals to your adjacent all over hypotenuse. So that will be adjacent all over 20 Newton. So if you make your adjacent this subject of formula, make the adjacent the subject of formula, that's going to be 20 Newton cos 30 degree. 20 Newton cos 30 degree. So that means for the horizontal, together with this 8 Newton, we are going to have 20 Newton cos 30 degree. Okay. So let's check for the opposite. You want to find the opposite and you have the hypotenuse with theta. So that's going to be sine 30 degree is going to be opposite all over hypotenuse. That means sine 30 degree will be your opposite all over 20 Newton. So make opposite the subject of formula. The opposite will be 20 Newton sine 30 degree. 20 Newton sine 30 degree. So that means together with this 10 Newton, this vertical component, together with this 10 Newton, you have 20 Newton sine 30 degree. 20 Newton sine 30 degree. So that is for this 20 Newton, which has horizontal component and the vertical component. This is the vertical component and this is the horizontal component, which is the same as this. So we are going to resolve for 5 Newton as well. 5 Newton has vertical component here and it also has horizontal component net. So we are going to resolve this one as well. We are going to resolve the vertical component of 5 Newton and the horizontal component of 5 Newton in the next slide. So now for the 5 Newton, we have a triangle like this, where your hypotenuse is 5 Newton. This is your right angle, and then your theta here is 60 degrees. So obviously this is your adjacent, while this side will be your opposite. So where cos 60 degrees is equal to adjacent all over hypotenuse. Your hypotenuse is 5 Newton. So make your adjacent the subject of formula. That will be 5 Newton cos 60 degrees. So what we applied here is trigonometry. That means that is for the horizontal component of 5 Newton, which means at this side we are going to have an horizontal component of 5 Newton cos 60 degrees. 5 Newton cos 60 degrees. Similarly, for the opposite, we are going to have sine 60 degrees, which is so opposite all over hypotenuse, which is 5 Newton. So make the opposite the subject of formula. That will be 5 Newton sine 60 degrees. 5 Newton sine 60 degrees. So what does that mean? It means for this 3 Newton, together with this 3 Newton, we have a vertical component together with this 3 Newton, and that is going to be 5 Newton sine 60 degrees. 5 Newton sine 60 degrees. How do we make use of that? That is what we shall consider in the next slide. However, bear it in mind, this 3 Newton is in opposite direction to this 10 Newton. So the implication is that we are going to subtract because the vectors are acting in opposite direction. Likewise, this 5 Newton sine 60 is in opposite direction to this 20 Newton sine 30 degrees. It means we are going to subtract as well. We will subtract this from this, you subtract this from this. So the result of subtracting this from this and the result of subtracting this from this will be added together. For this one, 8 Newton, 20 Newton cos 30 degrees, which is the horizontal component. Both are in the same direction. So we are going to add this and this together. But this 5 Newton cos 60, 5 Newton cos 60 is in opposite direction to 8 Newton and 20 Newton cos 30. So we are going to subtract 5 Newton cos 60 degree from the result of the sum of 20 Newton cos 30 and 8 Newton. That's what we are going to do in the next slide. So, as I was saying, we can see that this is vertical in the opposite, horizontal in the opposite. So bring this one to this side. So there's going to be minus that will affect this one. The result of everything here, the result of 3 Newton plus 5 sine 60 degree bring it to this side. You are going to subtract it from the result of everything here. So that will help us to resolve these 4 factors into 2. This will help us resolve these 4 factors into 2. So, I repeat, bring this one to this side. So there's going to be minus. That means you are subtracting the result here from the entire result here. The entire result for this vertical component, transfer it to this side and subtract it from the entire result of this vertical component, which is upward. So that's what we are going to do in the next slide. So this is your Ry and this is your Rx. X axis for horizontal, Y axis for vertical. So our Ry, that is the vertical component of the resultant vector, is going to be 10 Newton plus 20 sine 30 degree, whatever we get from that. Then you subtract 3 Newton plus 5 sine 60 degree from that. Begin to press your calculator. For the x component of the resultant, we are going to have 8 Newton plus 20 cos 30 degree, whatever we get, minus 5 cos 60 degree. Press your calculator and see what will give us. Okay. From my calculator here, I have 12.67 Newton for the vertical component of the resultant, and for the horizontal component of the resultant, I have 22.82 Newton. Press your calculator to ascertain the correctness. Ensure that your calculator is in degree while doing that. So what we are going to do next is to transfer this value into the Ry component and to transfer this value into the Rx component. Whereby you have your resultant R in between, and then we are going to find the bearing of, which is the direction, the bearing which is the direction of the resultant R. We are going to calculate the magnitude of the resultant as well as the bearing of the resultant. The bearing of the resultant. So we attend to that in the next slide. So, as you can see on the board, we have been able to resolve the factors into 2. The Ry, which is the vertical component of the resultant R, and the Rx, which is the horizontal component of the resultant R. So, make a vertical component here for the vector Ry. So that will give us a triangle, a right angle triangle. From here to here will be our bearing. Then you have your Rx, which is 22.8 Newton. You have your vertical, which is 12.67 Newton. Then you have your resultant R at the middle. So using Pythagoras theorem, we can determine the magnitude of resultant R. So our R will be square root of 12.67 square, 12.67 square plus 22.8 square, 22.8 square. So press your calculator. 12.67 square plus 22.8 square by Pythagoras theorem. That will give us the magnitude of the resultant R. So by my calculation here, I have R to be 26 Newton. By approximation, my R is 26 Newton. 26 Newton. So next thing we are going to do in the next slide is to find the bearing theta, which is the direction of the resultant R. To find the bearing, which is the theta, and the direction of resultant R, we are going to make use of trigonometry. Using trigonometry, and the trigonometry we are going to use, this is your adjacent, your RX is the adjacent side, and your RY is the opposite. So when you have opposite and adjacent and you have to find theta, then you use tan. So that means tan theta is opposite all over adjacent. And our opposite is 12.67 Newton divided by the adjacent 22.82 Newton. Newton cancel Newton. Press your calculator. What will that give you? So that will give you 0.5552. That is 0.5552. Hence, theta will be arctan 0.552. Arctan 0.552. So if you press your calculator, finding arctan 0.552, your theta is going to be 20 degrees. Your theta is going to be 20 degrees. Hence, magnitude of the resultant is what we got from the Pythagoras theorem, which is 26 Newton. 26 Newton, that's the magnitude. While the direction, which is the bearing of the resultant, is 20 degrees. So I believe with this, you can be able to resolve any factor that is more than 2. So what you have to do is to resolve them into 2, and then you apply the law that is appropriate. Till I come your way some other class. Keep studying, keep learning.